forgot to start the recording. Yeah, so anytime there's a technical thing like that, please just let me know. We're all in this shit together. So what about this one? What's the horizontal asymptote? What situation am I in there?
Would it also be 0?
Nope.
1.
The power, I'm getting it a few prior. Yeah. All right, wait a minute. Oh, I see. Okay. Sorry, somebody's asking me a question. Yeah, it's 1 because what situation? The degrees are the same. So what are the 3 situations? The degree is bigger on the bottom, y equals 0. The degrees are the same, y equals the ratio of coefficients. So what does that mean? That means if I had this over this, the horizontal asymptote
Is 1.
No.
No?
4/8.
4/8.
1/2.
Right.
And you simplify it.
So when I have the same degree, the degrees are the same. The horizontal asymptote is the ratio of the coefficients. That's actually a shortcut from the method we used the first time we saw this, which was divide by the highest power of x. So watch, one quick way you can get there. Now, just stay with me on this. Let me show you the hand waving way. I'm going to rewrite this for some reason. Why not, Jeff? The hand waving way to get there is if x gets really stupid big, how much does minus 7x matter to 4x to the 4th if x is 18 billion to the billionth power? That means nothing. That means less than nothing. This is not a technically official way to do this, but this is kind of the hand waving way. Does that make any sense? X to the 4th. If x is 18 billion to the 18 billionth power, x to the 4th just is so far ahead of freaking x that doesn't mean shit to it. It's like me giving Bill Gates a quarter that I found. Have I changed his bank account by a large percent? No, right? So this means basically nothing. 5 means nothing in the face of 8 times 18 billion to the 18 billion to the 4th power. And then the x to the 4th would cancel, so it's 1/2. Now that's not an official way to do it, but there's actually nothing wrong at all with considering it like that. Okay, so this situation makes complete sense. If the bottom power is higher than the top, the degree is higher than the top, then the bottom overwhelms the top. So it's going to go to 0. It's just going to keep decreasing and decreasing and decreasing. And it also makes, well, I don't know if it makes sense. The one situation that's not represented here would be if I do this is slant asymptote. And the thing that should make sense there is it's going to go to infinity for damn sure. If the top overwhelms the bottom, it's just going to grow unchecked. But it's going to go to infinity in a very prescribed way. That's the slant asymptote. Let me see. I'm getting a few more questions. I gotta catch up on my chat questions. Oh wait, that's an answer. Neat. Yes, exactly. Be careful. It's not. No. So okay. So when the bottom is a higher degree than top, y equals 0. End of story. Slant happens when the bottom is a lower degree than the top. Please let that make sense, because then can the bottom keep the top in check? No, it's not growing fast enough. The top is just growing crazy. It's going to go to infinity, but it's going to go to infinity following some line or something. That's the slant asymptote. So there's no ceiling or floor. It's just got to follow a certain direction to get to infinity, which is a neat thought. Let me see. I'll be your guide to infinity. You're welcome. I got one more question to catch up on, but I want to make sure people get this idea. Is that all right? Did you guys, here, wait a minute. I'm going to stop sharing this mess, which is probably fine. And then I'm going to share this. Here we go. Just to remind you guys, let's see who's paid some attention. If you go to modules and you go to unit 6, where's it 5? Where did we first do? Yeah, here we go. So rational functions. And over here, you'll notice, da, 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 like I told you guys, there's the three situations. The three situations. If the bottom is larger, it's 0. If the degrees are equal, it's the ratio of the coefficients. And if it's larger, there's a slant asymptote. That's the only three things that can happen. So it's one thing to memorize those. It's better to understand why they make sense, because then you don't have to memorize it as much as just do what makes sense. Okay. All right, let's do a problem. Let's find the slant asymptote for something. Somebody's asking that question. Let's see, am I looking all right? Oh no, my house. Okay. Have I done this yet? Oh, look at me. Hello. All right. There we go. Oh yeah. Figure out what the hell I was doing. You can do it, Joe. Sure. All right. Will that have a slant asymptote?
Yes.
Yes.
Yes. Okay. So how do I find it?
You look at the degrees.
That's what I do to see that there is one. How do I find what the slant asymptote is?
By long division.
Long division. Oh my God. Let me do something here for myself. All right. So then x to make x cubed, negative 2x squared, and 2x, change the signs. Negative 2x squared minus 2x plus 2. So many 2's. And then minus 2, right? Minus 2 minus 2x squared. I actually don't give a shit about the rest because it's going to be a lesser degree. That's what I need. I need the whole number part. This, whatever the shit this is going to be x blah, blah, blah. It's going to be xo blah, blah, blah over x squared blah, blah. It's going to go to 0. I just need the whole number part. Does that make sense when I say whole number part? That's the remainder. That's the whole number part. Is that all right? Because again, the whole idea is to let x go to infinity. So if the remainder always has a bottom degree higher than the top, and it does, it's going to go to 0. So it's just this piece that I care about. So then, yeah, then I would draw a wall at x minus 2, and that's how it goes. It's got to follow that eventually. Is that all right? Let me see. Did I get everybody's question? Oh, there it is. Yeah, I got to do one more question. All right. So somebody's got a question that from the practice quiz. Hopefully everybody saw that I did post the solution video for that. By the way, when you take quizzes, you can't use the book, you can't use your notes. It's a quiz. I can't visit your houses and watch you take it, so I'm assuming this is happening the way it's supposed to. Yeah. So don't sit there and watch my video as you do your quiz, right? Somebody goes, what? I would never. Is it? Okay. Somebody's asking a question about, given a quadratic, how would I find a domain, a restricted domain where it's invertible? So, let's see, what about this here? Sure. All right, so I want to find I want to restrict the domain so it's invertible. To be 1-to-1. How do I do that shit?
Switch X and Y.
That's how to find the inverse. I need to first restrict the domain so that it can have an inverse.
Don't you have to find the vertex first?
Because the whole problem is the parabola is going beautifully. It's like, oh, you look like you're going to be 1-to-1. And then it goes, what? You repeated yourself, stupid. If you would have just stopped here, you would have been fine. So if I find the vertex, I can chop it, either chop this part off or chop that part off. And that would make it invertible. Right there is where it started to just screw up. You're going great. If you would have just went like that, no. So I can erase part of this shit, right? So if the next part of the question is find the inverse, I might as well start completing the square to find the vertex instead of the shortcut, because I'm gonna have to complete the square to find the inverse anyway. I don't know if you guys remember this. No, okay. So how do I complete the square for this?
Divide 8x by 2.
Nope. I'm not really sure how to take that. It's sort of right, but I don't know if it's for the wrong reasons.
Do you factor out a -2?
You have to, because it only works when this is a 1. So what's left in here then?
Plus 4x. Minus 4x.
I just push the 7 out the way. Get out the way. I need some room. Now I think, what Brian was saying.
I don't know.
Divide
Oh, divide by
and then square.
Cut this guy in half. -2 squared is 4. So I'm going to add 4. So what did I actually just do?
Subtract 8.
So I better at the same time.
Subtract 8.
Nope. Then that was subtract 8.
Oh,
I've
you
already
add 8.
Yeah. You got to undo. That's the Indiana Jones shit. I want that gold statue. Let me. There we go. And he didn't balance his equation right. Freaking whatever. Indy. X minus 2 squared. All right. So what's the vertex?
Is it 2, 1?
Yeah, 2, 1. So what's the domain that would make this work? What's one way you can do the domain to make this work?
2 to infinity.
Yes. If you chop it at the vertex, then you'll get rid of the part that makes it not pass the horizontal line test. Let that make sense. I could have done -b/2a, but do you remember why I didn't? Because now I can do, like somebody said, I can switch the x and y and then find the inverse, right? If the question was just find the domain, I would have done -b/2a. And I could have gotten that quick and I would have been done. But if it said do the inverse, you might as well start it off, get the domain, and then keep going. Does that make any sense? Okay. All right. Anything else from homework stuff? Anything? It could even be, I don't understand that still, Jeff. That's always a valid question.
Where did you get the +4 from again?
Oh, okay. So right at this step, I'm looking at the inside here. What are the steps to complete the square?
What adds to 4 and more?
No. I'm not trying to factor anything. I'm actually trying to figure out what number do I add here so I can factor it? Nice. So the first step is to cut this in half, -2, and then square that. So if you forgot completing the square, you might want to go review it. Hint, hint. And I've got at least one handout up on Canvas related to that. All right, and then, so that's where we got. So that part you got to know. We went over completed square. Completed square is a tool that you need to always be ready to pull out when you need it. Completing the square. So make sure you review that because it's going to come up more times through the whole semester. Why? Because it's freaking useful as hell. So it's always half of this dude squared. Now, what was half of this dude? -2. So how does this thing factor x minus 2 squared? If you don't believe me, what multiplied before it had to be -4, -2, and -2. Bam. So I just factored this. But the shortcut is this guy will always be what you got when you cut him in half. That only makes sense. It came from how we developed completing the square. We knew that from when we developed it. We knew that back when we did it. And so I had to, so I just put a +4 there, which is actually -8. So I better add 8 at the same time. So I overall didn't do anything. Okay. Let me see. Somebody, all right. So many private chats. I can't keep up. All right. I did that one.
Can you go over how you got the vertex for that problem?
Yeah. Once I get it in this form, you have to be able to see the vertex. That's the whole point of this form. In fact, I think the book calls it vertex forms. No, it calls it standard form. I call it a vertex form. So that it'll be 2, 1. That's the vertex. How can I see that now, especially now that we know transformations? Because that would move it right 2, and that would move it up 1. That's why the vertex is 2, 1. Because normally it's.
Thank you. My brain's just tired today.
Somebody has a question about the underlined 4. Did that get answered?
I asked you answered my question though.
Yeah, and then the second question you asked, that's not quite right because A has to be 1 for, so it's sort of right what you're doing there. Right, because if A is 1, that's exactly the steps we take. Yeah. How did it turn? And then I talked about that, so everybody's cool with that now, right? Okay, good, good, good. I'm caught up. Okay, thank God. All right, anything else? Which again, it could even be, can you do another example of completed the square, Jeff? Because it sounded like it was important. That would be a valid question to ask if somebody wanted to ask that.
Can you give another example of completing the square, Jeff?
No. Yeah, okay. All right.
Can you do with some ugly numbers?
Sure. My favorite. You want to do it with some letters? No, let's do it with letters. Let's do oh shit, strap in. Here we go. First step. No matter what the hell's going on, what do you have to do? What needs to be here for this to work?
A 1.
If you're an x squared, so you get rid of the 7.
So you take a 7 out. So what's this going to be?
3
Stay
over
with
7.
me. 3 over 7. There you go. I like it. Because I divided a 7 out. So 3 divided by 7 is 3 divided by 7. And let me push that 111 over there. I could have put whatever the hell I want to over there. It doesn't really matter. It's not going to affect me. The steps don't change. Steps don't change. So some people give up right now. And that makes me so sad. Especially when it's like my 280 students. They're like, I can't do fractions. I'm like, get the hell out of here. Calculus 2 can't do fractions. Shut up. So what are the steps? What are the steps?
Take half of -3/7 and square it.
Of -3/7. There we go. So that's -3/14. And then the second step, square. All right. Right. I mean, I brute force that thing. I know the steps, so I did them. Is it pretty? No. Do I care? No, not yet.
So when you get it into standard form, then you can switch the x and y to
Yeah, you get it into standard form to see where the vertex is, which tells you where to cut it for the domain.
yeah, and then when you want to find the inverse, can you switch the x and y while you're in standard
X and
form?
Y.
Okay.
I just want to be careful about doing that too early because you might confuse yourself when you get to the step. Yeah.
And we're not allowed to use the shortcut, right?
So the problem is, if I need to find the inverse, I have to do this. If I just want the vertex, use the shortcut, of course, especially on this data, right? But let's pretend like the question here is find the inverse. So I have to do this anyway. There's no way around this shit to find the inverse. There isn't. Does everybody understand why? I am getting, I know I'm not done yet. Hold on. I am getting stuff like find the inverse of this, and somebody does this. And then they subtract y squared and they subtract 5 and they divide by -3 and they circle it because they solve for y. Okay. Did you solve for y? No. So there's y's that are not like terms, which is why I have to do this slightly freaky way to do it. I got to consolidate all of my variables that are all over if I can get them in one place, I can do the inverse. They're in too many places here. I can't get one of them alone. There's too much shit going on. Let me compact them all into one thing. That's why this completed square is so useful. All right. So where does that go?
In the parentheses.
Yes. Don't let the numbers confuse you. Now here's the other worst part, but this isn't that bad. What I actually just add.
You subtracted.
No. I added what? What did I just add?
7 times that.
Yes. 7 times 9 over 196. That would actually reduce, because remember we got it from 14, this last 14 squared. I don't care about that. That would be 63 over 196, so I better at the same time subtract, which is what I think you meant, Brian. That's where it's got to be mine. I added it, so I better subtract. Now, the numbers are ugly up here, right? But for the most part, I'm just writing them. Have I really had to work with them that much? I want you to really notice this. This is probably one of the grossest problems I can make for completed the square. The numbers are gross, but I haven't had to do much with them. Right there's the first place I'm going to have to do something with them because I got to combine this. So let's see. So that's where I probably, now watch this. How does that factor without doing any work?
X minus 3 over 14.
Yes, the first step tells you. The first step tells you how the little dude's going to be factored because of how we created completing the square. And to do that, I would probably go ahead and reduce this. So watch this, you ready? That's 14 times 14, right? That's where it came from. So the 7 on top reduces when one of the 14s makes it 2, twice the other 14 is 28. And then I just multiply them by 28. I don't care about the rest of this shit. You can do it. Okay. And then I could see where my vertex is and all that kind of things. All right. So was that as nice? No. Was it as hard as you would expect it to have been? No. You really didn't have to do too much until you had to get to the point where I had to put these together. And even that sort of blind, just brute force.
I have a question. What if it was 7x cubed?
Then there would be no point to it because it wouldn't be parabolic.
Oh, okay.
Yeah, sorry. That one, see, this is actually an excellent question because somebody got what they want from this crazy ass problem.
Yeah.
Okay. So the minute you start getting x cubed plus something x squared minus something x plus 8, whatever, then you start getting this kind of thing happening. Is it as easy to restrict the domain here? If you cut it off here, it's oh shit. So you could cut it off, all this shit cut it off, but then you sort of lose the function completely. Does that make any sense? So the minute you get above squared, I'm not saying it's impossible to find an inverse, especially if the domain is already restricted for physical situation, right? If the domain is restricted, like it can't be below this anyway, none of this can exist, then that piece of it is invertible. Is it easy to find that? Which is what I think your question is, how do I find that? That is not easy. That is not easy. Yeah. Very often we start doing what's called numerical methods, meaning we let a computer worry about it. Are we there yet? No. Somebody's asking. All right. All right, anything else? I love this. Actual questions get me excited. I don't know if you noticed that. Okay. How about you?
Can you
The
do
well dry. Oh, what's up?
on 6.2? 54.
54, is that what you're saying?
Yes.
Let's see. 54. All right, here we go. So this one says, prove the conjecture made in 53. Oh, okay. And then you explore and discuss those graphs, make a conjecture. Yeah, did you think about 53? I might not have assigned 53. I'm kind of surprised I assigned 54, but maybe I did. Let me see. Where am I at? Is that the right problem? That I just, you're 6.2, right? 6.2, 54?
Yeah, 54.
Okay. Oh yeah, I did. Oh, I'm so evil. I love it. So you have to go back to 53 to do that problem. Did you figure out 53?
Yeah, but I was kind of confused on 54.
Yeah, so it's if you analyze the graphs of these things. So, all right. We actually talked about this a little bit when we did the shifting on one problem and the A came out to be 2. I don't know if you guys remember this, but then the base was also 2, so I could actually combine them and it turned out to be a shift on the x-axis. I don't know if you guys remember that. It was momentous for me. This is kind of silly, to be really honest. Help me out here. This is kind of funny. When would you, let me write, can I write like this? Sure, yeah. So when would you add exponents? In what situation would you add exponents?
When you multiply exponents?
So what would be here to have gotten there?
4 to the 2.
-2.
Yeah, and what is 4 to the -2?
1/16.
I believe.
Which is what they have, right?
Yeah.
So to be honest, that number 54 is easy. It actually relates directly to what we did with when we figured out we had a situation like this, a to the 2 times something, and a turned out to be was 2 to the x, and a turned out to be 2, which I can then combine with this and make it plus 1, which is really exactly this in reverse. So if this is 1/4 squared, that actually leads to a shift. What would this shift? How would this shift it? What would
To the
this shift?
right.
To the right too. So if I multiply 4 to the x by 1/16, that would be like a compression, right? Right, 1/16 of it. But if I rewrite it like this and this, now it's a translation. It's just a movement of 2. That's what the point of that is, and that's why it's a bonus problem, right? It's one of those extensions, and I'm not going to talk any more about it because of that fact.
Why did you make it a -2 if it was a +2?
No. So I really wanted you guys to that I made this plus a -2. Is that cool? It was -2. I made it plus a -2. So when I said when you add exponents, you guys could actually see the addition, right? So when you add exponents, when you're multiplying like bases. So this would have come from 4 to that and 4 to that.
Okay.
Is that all right?
Yeah. Okay. I got confused.
And by the way, that problem, hopefully that's enough for that, but that problem that I couldn't figure out on the fly that I thought the book was asking for too much, it really made me angry at myself because this is a really good thing to show you. And I didn't even think about the implications. So you have these these possibilities here, right? How can I rewrite this? Do you guys see how I can rewrite this as this? Does that make sense? Because what would I do with those? I would just multiply, right? So do you see how if I call this B, that is basically this? So that problem that I was trying to force it to be this, I think I just got it in my head that I wanted them to give you a problem using this. And I'm very used to finding this rate, but they wanted you to find the rate represented by this. So I thought you had to use a natural log when actually it was exactly like the problems before, the ones that I referenced that had points that they gave. So it's the same exact kind of problem. So you don't need natural logs to solve it. Because whatever I found out for R, e to the R would be the B they want. I don't know if that makes sense. That is kind of cool though. They're actually, this and this are the same. It's just B is e to the R. All right. So, let's see, anything else? I think I might have gotten to the bottom of the barrel on questions. Okay, so let's look at something. Actually, I'm just going to keep going on the board, I think. Yeah. I'm going to show you a couple more equations from section 6.6. And then I'll probably let us out here early so you guys can get started on the quiz if you want to. Look at, actually, I'm going to pull one out of the homework just so I don't make something freakier than they're going to want you to do. Yeah, let's do one like the last one we did last time. And then I want to show you, come on, you guys have to do what I'm thinking. No, you don't? Yes, you do. Sweet. Aha, too bad. I could do one of my favorites because it's in there. Aha. All right. So the kind of problem we did last time, let's warm up to it. So let's start off with a nice one. How would you solve this here?
Log base 3 to the negative 2 equals x.
Not quite.
3 equals x.
I would just say 3 to the negative 2 equals x,
Yes.
right?
So it's either in logarithmic form or it isn't. So when I rewrite it, there should be no more of this guy. 3 to the negative 2 equals x. So x equals
1/9.
1/9. Okay. All right, so that's nice. That's actually that's an equation we could have solved after the first time we talked about logs, because that's one of the most basic things we got to know about logs is how to rewrite it in exponential form. Okay. And then the one we did yesterday was more like this. Let's see if I can make one that works. Would that be nice if I can make one that works? I think so. Oh, Jeff. All right, let's see. All right. Yeah, okay. All right, that should work. Let's find out. Ooh, that's gonna be so gross. I love it.
Don't you multiply x and x minus 20?
Yeah. So I know how to solve when I have a single log equals a number. That's relatively easy. Here I can't do this because there's too much shit happening. So if I can consolidate them, and of course I can. It's addition, so it'll be log base 5 of x times x minus 20. I'm gonna have to take this up here. Man, I should have gotten the bigger one. It's all right, Jeff. It's all right. Is everybody cool with that? Right? The addition of the logs is the log of the product. Bam. And now we can do exactly what we did earlier. What would be 5 to the
third.
Yeah, so I get, what is 5 to the third power?
125.
Cool. So of course, what do I do to solve this?
Factor out an
Yeah,
x.
right.
Start
Oh,
125
yeah.
So this is nowhere near as bad as I was hoping it would be. This is easy. It's only one thing that could work. There's not that many ways to factor that because it's 5, 5, 5, right? So it's got to be 5 and 25. You guys see that?
Yeah.
5 and 25. And of course, to make it negative 20, the 25 is negative. And then you get 25 and negative 5. Are both of those answers good? What would make an answer bad? If it was one of my least favorite numbers. No. If it makes one of these guys or both of them freak out. So which one of those can these not handle?
The negative 5?
Yeah, the domain of logarithm is positive numbers. So don't just automatically throw out negative numbers because there might be something inside that makes it positive when you put it in. But when I put that in, these are obviously both negative. So that's not the answer. That must be the answer because it leaves them both positive. So why did math do that to us? Well, if this and this are negative, when I multiply them, doesn't it become a positive number? So that's why math had an answer to this, because we did something freaky here. We lost information about the fact that they could both be negative. All right. Okay. All right, so I know you're excited about what must this equation be that he's excited is in there. Let me show you. So what if I have this? What do you got, Jeff? Let's do, sure, we'll be nice.
Do you have the 20 to both sides first?
Nope. I appreciate that though. This is weird. But do you notice something? Remember, remind me, why, how do you know right away? Well, let me make one that works. There you go, buddy. How do you know right away that this has a chance of working to factor? How do you know that's got a chance to directly factor?
Because the middle term is half of the first term.
The middle power is half the first power. Is that true here?
Yeah.
Yes, it's true. Holy shit. Okay, so what I can do, are you ready? This is a really cool method that's going to come up over and over and over again throughout mathematics. Some of you guys might have used this already. Do you know what e to the x is in this equation? You know what it is? What's e to the x equal? You know? I don't know either. So let's call it, I don't know what e to the x is. So algebra says, if you don't know what something is, call it a letter. I don't know why I'm calling it the Greek letter mu. Just call it u. I taught stats earlier, that's probably one. I don't know if anybody's ever seen that, the substitution method. So watch what happens when I do that. What's u squared? If I say u is e to the x, what's u squared?
E to the power of 2x.
2x. So what does this look like now? E to the 2x is u squared. E to the x is u. Can you factor that now? I mean, to be honest, you could have factored it here, but it looks a little weird.
U minus 10 and u minus 2 or plus 2.
So u is 10 or u is -2, but what was u? Don't stop here and circle that shit. That doesn't answer my question because my question involved x's. So what do I put here?
2x?
No, u is not equal to 2x.
Oh no, e a to the x. Sorry.
Which one of these I can tell is not going to have an answer? I don't have to mess with it.
-2 can't be an answer.
No answer comes from that. Because e to the x is completely above. It doesn't cross, it can't be negative. That's a quick way to say what I'm saying. This one, what's the answer? What do I do to both sides? How can I kill the e? Kill it.
Take
Kill it.
natural log of both sides.
If I kill it, then I got x. X is natural log of 10. Done.
What if it's not a half of the exponent, the first exponent? I mean the 2x.
Yeah, then that's, that's excessively gross. I want you to, we're not going to do this. But even if I had something where that wasn't true, I could replace the stuff with u like I did. And then you would have like a u cubed here if it was e to the 3x, right? And then you could do synthetic division with u.
Okay.
It's actually not that hard. It really is. Once you get the e out of the way and you focus on u, you can do all the shit we did before. List all the possible factors, get all the ones that work. And once you get like u equals 2 and u equals -7, then you bring back in the fact that it's the x and you solve it like we just did. So it really isn't that crazy, but it is kind of like multi-level stuff. Maybe. Coolness. I've actually never done what I just said, just to be clear. I just now figured that out. I don't think I've ever done that before in a class anytime. But that would work. So that's kind of nifty. Okay. Did I miss something? No. All right, guys. I think that's plenty. Sure. Is that all right if we leave like excessively early today? Is anybody upset about that? I think I made your quiz so you can access it. Let me double check. Where are you, quizzes? Here you are. Yes, you're going to be able to access it at 6:20, which is a minute away. Which is amazing. It's not like I planned this out, but it seems like I planned this out. All right, let me know if you have any questions and you need to hang around. Otherwise, you can head out and you can start on the quiz now if you want. Wait till tomorrow.
Thank you.
You're welcome,
Thank you. Have a good day.
guys. Certainly.
Yeah.
All right. Everybody
Hello.
okay out there? Yes.
I actually wanted to say that I haven't finished all the homework that was due before the quiz. I had a, sorry, go ahead.
So I don't need to know unless you want to tell me, but I don't need as long as you did enough to be ready for the quiz. That's important. Because if you turn something in that's a little bit late, you're fine.
Okay,
gonna-
yeah.
So
Okay,
really, 3 days is because getting the homework done is the best way to be ready for it. So I try to
exactly.
force you as much as you can. But if you're not quite done with something, it's not the end of the world.
Yeah, no, my son actually got sick, so I had to deal with going to emergency and everything like that this week.
I guess he's okay. Is he all right?
Yeah, he is. He had a viral infection.
Oh, okay. Wow.
Yeah.
All right. Glad he's
Me too. Okay. Well, thank you very much. Have a good night.
all right. See you tomorrow.
Okay.
Luke, are you out there? Luke, I'm gonna head out. Okay, I'm gone.